Welcome back. And we've been dealing with arguments that are true with certainty or not. But oftentimes there is math and there's probability and there are statistics that are couched in the arguments that we'll be addressing in this class. And for this, we need to understand the difference between induction and deduction. Validity and soundness are properties that only apply to a certain class of arguments known as deductive arguments. Deductive arguments are one whose conclusion follow from the premise with absolute certainty, whereas inductive arguments are probabilistic arguments. And it's up to us, not only as logicians, but also as budding economists, to determine what it means to have this high level of probability. So put differently, an example of a deductive argument is, some pigs have wings, all things with wings sing, therefore some pigs sing. This conclusion must flow with certainty from these premises. Everyone has one and only one biological mother, full sisters have the same biological mother, and no one is her own biological mother. Therefore, there is no one whose biological mother is also her biological sister. This must flow with certainty. What does an inductive argument look like, though? Well, here are two examples. Every ruby discovered thus far has been red, so probably all rubies are red. Now, we can't say with certainty that all rubies are red, but we can make this probabilistic argument. Similarly, Marta is 5 years old, and polls show that 87% of 5-year-olds believe in the tooth fairy. Therefore, we can induce that Marta probably believes in the tooth fairy, but we can't deduce with certainty that Marta does. Keep in mind, inductive arguments don't need to be fully true. Chemically, potassium chloride is very similar to table salt. Therefore, potassium chloride probably tastes like table salt. And those of you who are engineers or chemists in the audience know that this is very, very false. So what's the difference between these two? If the premises are true in a deductive argument, the conclusion is necessarily true. Or if the premises are true in an inductive argument, the conclusions are probably true. The difference between conclusive evidence and good evidence, the difference between impossibility and unlikely, and the difference between inconsistency and consistent to deny conclusions in a case where the premises are asserted. So as an example, and I'll drop this example into the lecture notes below, maybe we should all think about what Sherlock Holmes calls deductive arguments, but we all can see now is actually an inductive argument because it's making these probabilistic assertions. Much the way that good deductive arguments, arguments that can be argued with certainty, have validity, we also have measures of what makes a good argument for inductive arguments, and that's strength. And what makes an inductive argument strong is if the premise probably follows from if the conclusions probably follow from the premise. So all recent US presidents have been college graduates. It is likely that the next US president will be a college graduate. Now, this doesn't mean that the next US president will be one with certainty, but this is a strong inductive argument. And here we have a picture of the Oval Office. An inductive argument that is not strong is weak. So, most US presidents have been men. It is likely that the next US president will be a woman. Now, this is not saying that it's not likely. What it's saying is this does not probabilistically flow from the premises. I dream about monsters, you dream about monsters, therefore everybody probably dreams about monsters. Again, it's not saying that it's not true that everyone probably dreams about monsters. It's saying this doesn't flow from our premises of two people dream about monsters. And we'll talk about this a little bit in the next lecture. So it's up to us as logicians, as economists, as leaders to determine what this degree of strength we're willing to support is. Is it somewhat strong? Is it very strong? How much support is there for the conclusion? So let's talk about inductive probability in the sense of weather. According to the National Weather Service, there's a 60% chance it'll rain today, a 70% chance it'll rain today, a 90% chance it'll rain today. Certainly, the higher the probability, the stronger the inductive argument. But it's up to us to assess what this strength means, particularly when we're deciding whether or not it is likely that it'll rain today. And with that, we'll wrap up this mini lecture video. We'll come back in the next one and talk about what some of these probabilistic and statistical fallacies might look like.